Alright, class, today we're going to take a look at proofs that are not valid. Math is a very powerful tool, and some people use it to make claims that, while they might look on the surface to be true, they aren't. We're going to start by taking a look at a general proof and some of the things that can go wrong with it. Here we go. It says, athletes do not compete in both the Summer and Winter Olympics. Hayley Wickenheiser has represented Canada 4 times at the Winter Olympics. Therefore, Hayley Wickenheiser has not participated in the Summer Olympics. Tia read these statements and knew that there was an error. Identify the error in reasoning. Well, there are 1, 2, and 3 statements here. And the one that I underlined with a squiggle, athletes do not compete in both the Summer and Winter Olympics. So it says, athletes do not compete in both the Summer and Winter Olympics. That statement right there, that athletes do not compete in the Summer and Winter Olympics, I know that to be false. That's an example of a false assumption. I know Hayley Wickenheiser, she competed both in softball and in hockey. There's also Clara Hughes, who's competed both in cycling and speed skating. Alright, so sometimes people will create a false proof by using a false assumption. Alright, here's a second example. Alright, and it says, Bev claims that he, probably should be she. Bev claims that she can prove that 3 is equal to 4. And this is how the story went. She said, let A plus B be equal to C. Alright, that's a reasonable statement. Pick 3 numbers such that A plus B is equal to C. Then she went on to rewrite A as 4A minus 3A. That's perfectly fine. And she rewrote B as 4B minus 3B. And she wrote C as 4C minus 3C. Alright, no problem there. Then she went on to rearrange the equation. 4A plus 4B minus 4C must be equal to 3A plus 3B minus 3C. Noticing that the left-hand side has a common factor of 4, and the right-hand side has a common factor of 3, we now can divide each side by A plus B minus C and A plus B minus C to get 4 equals 3. That is interesting. It looks like all of the math looks correct. But there is one very, very, very subtle mistake in this. Let's start out with the first thing. A plus B is equal to C. There's nothing wrong with that statement. In fact, if we arrange it, we know that A plus B minus C must be equal to 0. Oh, and this gets us to the rub of the mistake. Right down here, we divided by A plus B minus C, but that is the same as dividing by 0. And so we know that we have broken some of the laws of algebra. Right? Right, and that's not allowed. Right, that's a very subtle mistake, but this person is divided by 0. If you allow division by 0, then 4 could be equal to 3. Right, one last example on this page. It says Liz claims she has proved that negative 5 is equal to 5. Well, this is pretty straightforward. Alright, she's claiming that negative 5 is equal to 5. If I square each side of the equation, I get 25, and 25 is always equal to 25. Then I can take the square root of each side, and we know that there are two possible values. Negative 5 is equal to 5. Alright, so there's a subtle mistake in this, and it's called circular reasoning. Alright. Basically, that means that Liz assumed what she wanted to prove. Right at the start, we said negative 5 is equal to 5, and so if we square them, we get 25. And then we took square roots, and we know that negative 5 is a square root, and 5 is a square root, so we must be good. Alright, so on this page, we've highlighted 3 different things that can go wrong in proofs. Right, you can make a false assumption right off the bat. Maybe you're starting from a statement that's not true. If you're starting from a statement that's not true, your proof will not be true. You might have some sort of weird division or accidentally break some rule of algebra. And finally, you could have circular reasoning.